Recently, I took PowerApps for a spin, and I wanted to show you an example of using PowerApps to create a loan calculator. So I'm going to step you through this particular scenario, how I built it, and also show you what it looks like in Teams. So let's get started. So basically what I wanted to do was be able to create a loan calculator that showed a full repayment schedule, basically a amortization schedule if I'm paying a mortgage or any type of loan where we have a principal and interest situation. So I built this in PowerApps. Let's take a look. Now there's a few different components to this app, and I'm going to, like I say, step you through all the different components. But first of all, this is a Canvas app. There's no actual data behind this. There's no dataverse. There's no data tables. This is all done in memory based on values that I'm inputting into text fields that you'll see. I'm also using a couple of preview controls here, in particular the data table, in order to display the values from the loan calculator. So as I say, let's step through this. So first of all, I have a bunch of input fields on my screen to capture the various details of the loan amount, payment frequency, etc. A calculation here in terms of the number of payments, which is based on this payment frequency field. This payments frequency field is a drop-down, and the way that I'm getting the values into that payment frequency field is via a onStart method on this particular app. So I'm creating a new collection, putting the various values into that collection, which I then use as the source for this drop-down, which you can see over here. So a bunch of input fields for amount, frequency, term, etc. So that's kind of the easy part. Then based on those values that the user enters, I want to be able to generate this table. So let's take a quick look at a preview of this. So very simply, enter my values, hit the calculate button, and that does the full repayment schedule across the term of this loan. And just to make things a little bit fancier as well, I basically plotted the principal versus interest on a graph here. So you can see again, reducing amount of interest that you pay versus the principal amounts over the term loan. Okay, so that's basically what it looks like. Now, the tricky part with this was then building this repayment schedule. The reason why it was tricky is that PowerApps doesn't have a concept of loops, and so part of building this table is you need to look at what the current balance is, look at the balance post that to figure out then what your principal interest payments are, and the various calculations. And I used the web because I'm no maths genius at all to look up the various formulas that would give me the values here and use that as the way of actually creating this table. But I needed to be able to look at the opening balance and closing balance and use it as part of my calculation. So that posed a bit of a problem because it's the first time I ever used PowerApps. But I was able to get around this, and I'll show you now how I did this. Now, whilst there is no concept of looping through a collection, looking at the current row versus a previous row and doing calculations on that, what I can do, which is really clever within PowerApps, is the ability to essentially create a collection, which is a table or list of data records, and then add to that collection and refer back to the previous collection I created as part of building my new collection. So I've got kind of nested collections, if you like, that create the new collections, and I'll explain that a little bit further as we go. So to start with, what I need to do is set up a bunch of variables based on the inputs that the user puts in the screen, because these are used as part of my calculations, and it's quite complex in my mind, maths required to actually do the calculations, but the great thing is we can actually do this within PowerApps. So that's the first thing, create these variables to use further on in my calculations. So interest rate, payments per year. And by the way, I'm not just doing this on a monthly schedule. The user has a choice of paying weekly, monthly, fortnightly from memory. So it's not a simple matter of just dividing by 12 in my calculations. I actually need to know, well, actually, what's the frequency of payments we're dealing with here. So that's one of the things. And also from one of the payments, sorry, one of the calculations that we need as part of our overall calculation is what is the actual interest rate for that particular period. And so we divide this by payments per year to get the interest rate for the calculation as well. So it's a fraction of that interest rate. So first thing I do is I create a collection called payments, and I add a couple of columns here. Now this sequence column is really clever. What this enables me to do is generate actually a list of records in that collection based on a running sequence. And how this works is this n value, which we refer back up here, is our number of payments. So this is the total number of payments across the time of this loan. And what this is doing is using that as our end value. So it's going to create the number of records equal to n. So if my number of payments is 100, it's going to create 100 records. It starts at the value 1 and it increments by 1. So in essence, what we're going to get here, if we've got 100 payments, we're going to get a value that starts at 1 and ends at 100. And it actually creates a value column in this collection. So my vAPayment collection will have a value column, which starts at 1 and ends in 100. And the first thing I do is actually calculate what is the recurring payment that happens over that period of a loan. Because this is a principal and interest type of a scenario here, I'm going to have a fixed payment across the lifetime of this loan. And this calculation gives me that fixed payment amount. So that's the first part. Now, remember I said there is no way to iterate across this current collection, this vAPayment collection, and refer to values within rows, and then basically kind of create calculations on the fly. But what we can do is create a new collection. So in this case, vABalance, bringing in the previous collection, vAPayment, which we created up here, and reference the columns from this collection in this collection. And that's a way that we can build up these columns based on calculations that require values from previous fields. Because what we can't do also within this collection up here is refer to a field that I'm creating within that collection. So I can't say, for example, use this payment column in a calculation within this collection. I have to then refer to it as part of a separate collection. And that's the way I'm building up that table using these calculations. So now we have a payment. I want to basically be able to work out, well, what's my opening and closing balance, because I'm going to use that again further down for other calculations. So in this case, I've got a formula here to calculate the closing balance, and I also have a formula which I repeat based on the previous row in order to do this. So let me explain this further again. So my balance is based on the overall loan amount using this formula based on the current row. So that gives me the loan amount times these various values based on the current row. Whereas my opening balance, I'm referring back to a record previously in order to calculate my opening balance. So if the value is 1, it's the first payment, so it's actually the loan amount. Otherwise, I'm referring to the row previous to this amount to generate my formula, and that's the way we have to build this. The next part then is I've got my balances, I've got my payments. Now I want to figure out my principal, and principal is calculated using our opening balance minus balance. So these fields that we create up here, and this is why I need to do this the way I'm doing this. I've also added some calculations in here to know what year this particular payment is happening within. So if I'm paying this loan over 10 years, for example, what year am I in for this payment? And the reason I'm doing that is because I want to be able to plot on this graph over here the total interest and total principals over the years. So this isn't strictly necessary if I just want to produce this table here because I'm not actually showing the years. I'm just showing the actual payment increment here. But because I want to plot this graph, I'm also doing some calculations here to figure out, well, what year are we in? And then finally, the final part of actually creating my table here is then to figure out what's our interest payment. And I'm doing this with payment minus principal, which then gives me the interest component within here. So whilst this might seem complex, if you actually, and I'll post the formulas in the as part of launching this video so you can understand this a bit better. It's a good way of actually building this table based on doing calculations with fields that I'm adding dynamically as I create my collection. And I have to do this in stages because, as I said, there's no way of doing that entire thing just within this particular collection because I'm creating these values on the fly, and I can't use a calculation in this collection or any other collection. Sorry, I can't refer to this field in the same collection because I'm creating that field within this collection. So hopefully that makes sense, how we're building this up. Now, if all you're interested in is how we create the table here and the list of payments, etc., you can stop at this point in terms of formulas, because all those values, that collection at this point is bound to this control. And this is a data table control. And by the way, this is actually in preview at the moment. So I am using a control that's actually not available in general release. It's actually a preview. But that VA final table collection that I'm creating in my script is bound to this data table. And we have the fields mapped from that collection to these table values over here. So that's how we're doing that. All right, so just to be clear, my calculate button is creating all the collections, and then I bound that collection to this data table and the various columns to that data table. And then, as I said, because I wanted to create this graph, and I didn't want to do this over every single period because the series here would get really messed up if I had, say, 200 payments and I wanted to do this by year, then that's why I'm doing the additional calculations here to figure out what year we're in. I'm then creating new collections and doing a group by on year. I'm then doing summaries then of total payments, interest and principal within that collection so I can produce the graph on the right hand side there. Again, I'll post all these formulas into the chat window, as part of this video so that you can see what they are. And so this VA graph collection, again, I use that as the basis for this particular chart, and it's using the properties from that collection to produce that chart. And that's it, basically. Once we have that collection, I can bind it to this table. There's no additional calculations or formatting going on with this table other than I am basically masking the data values on those columns so that we get a nice way of displaying payments. Otherwise, we get fractions of numbers. So I'm rounding and doing things like that using these text items to get a very nice display here. The only other thing is also utilizing the sum values to create these running totals, or sorry, the total amounts for both interest, principal, and payment. So we have the total amounts down here as well. I'm not entirely sure this is the absolute optimal or best way of doing this, by the way. It's just the way I found to do it. I think the other thing to point out too at this point is I wanted to do everything within collections. So I wanted to do all the calculations, create my collection, bind it to this table, so that way I'm not relying on the table itself, creating formulas on columns within the table. I wanted it all to be very neat and tidy within that calculate button. So that's the way that we do that. So I run this again. You see, we can do various different types of calculations, etc. Change it to weekly, whatever we want. So it's a great example of sort of the power PowerAutomate to be able to generate these types of apps. So that's how we built the app. Now, the other part about this too is I actually wanted to be able to add this app into teams. So the example here is if we have, say, a retail banking, we're a bank and we've got a retail banking team, I can embed these types of calculators like a loan calculator into teams. And so if I have a bunch of users who retail banking users, for example, who do these types of calculations for customers, I can embed these and can embed PowerApps directly into teams. And if you want to know how to do that, it's really, really easy. Let's get out of preview run mode over here, go back to our PowerApp builder into the admin center, and I just simply do add to teams, and that will bring me up a dialog here, ask me where I want to add it, etc., etc. Another thing just to point out too with PowerApps too is if I wanted to be able to this is within a particular tenant. If I wanted to share this across tenants, we can actually export this as a manifest file, as a package, upload it into another tenant, add it to a Teams in a different tenant, do all those things, and can also share potentially the app that way as well. So again, just an example of the power of PowerApps to create an app like this. I'll share all the formula details when I share this video, and hopefully that makes sense. Feel free to ask questions if it doesn't. But just quickly again, calculate button, which is creating a collection, which is bound to this data table here. Bunch of variables to use within our formulas. We're then building up the various columns that we see within this data table here based upon creating formulas and adding those to collections, which then we add to our other collections. That basically gets us to this point of creating a final table with all of those things. Ability to also graph that and see that over time as well using the chart component within PowerApps. Hope that's been helpful. Thanks for your time today.